Dear students, Salam Alaikum. This is the first topic in Physics 170L, Introductory Physics Laboratory for the semester Spring 2020-2021. The most physics books in their first chapter have something to do with units or sometimes some areas of mathematics needed to understand the rest of the physics book. Sometimes two chapters are there on units and mathematics, one chapter on units and one chapter on mathematics. This is a laboratory course, and in this we do not need any new mathematics. So we just have one chapter on units, which we'll be doing now in this video. Now there are many types of units. Like for example, we hear about kilometers, meters, centimeters. Some people use feet, yard, miles. In some cars you can see miles per hour. In some cars you see kilometers per hour. Now we need to have a consensus to have the right set of units for the scientific calculations. So we'll be using in our university SI system of units. SI system means International System of Units, and this system of units was fixed after a series of meetings in 1960. So we don't have to know the precise historical details. In this system of units called SI system of units, we have 7 base quantities, and the corresponding 7 units. Now, what are the 7 base quantities? The 7 base quantities are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Now, the three things length, mass, and time we see every day in our life. Experience them in some form. The room may be big or small, the table may be big or small, some object may be light or heavy, and we have some notion of time, that the time is flying, time is going away, time is passing away. So we have some notion of these things. Now in modern life we are also using electric current, that is the fourth quantity. The fifth quantity is the temperature, but we have to call it thermodynamic temperature. The sixth quantity is amount of substance, which you normally see in your chemistry calculations. And the last seventh quantity is luminous intensity. This has to do something with the brightness, and we'll not be needing all these 7 quantities and 7 units in this course. The focus will be more on length, mass, and time, as all your mechanics units are centered around length, mass, and time. But we have to know that there are 7 base quantities and 7 base units. There is another system of units where the fourth quantity, the electric current, is not there. They use electric charge as a base quantity. In the SI system, we use electric current as a base unit. Now, you should not use the word basic. The correct word is base. So you have 7 base quantities and 7 base units. So for length, we'll be using meter, and the symbol is small m. For mass, we'll be using kilogram, and the symbol is kg. Small k, small g, lowercase. For time, we'll be using seconds, and the symbol is s. For electric current, it is ampere, and the symbol is capital A. For temperature, we will be using Kelvin as the base unit. It's not centigrade, it's not Fahrenheit. Because scientific calculations are carried out in Kelvin and not the other units. Amount of substance, mole is the unit, and we write MOL. This you must have seen in your chemistry classes. Luminous intensity has to do with brightness, and the unit is candela. Candela word comes from the word candle, and CD. Now, luminous intensity you will not be doing in any of your courses in all probability. Mole will be there in your chemistry calculations. The temperature is used in your thermodynamics calculations, in your both physics and chemistry. The electric current will come in your physics and engineering calculations like electrical circuits, the batteries, the engines. You will be seeing how much current they consume. So that will be done in other physics courses. So you should know that there are 7 base quantities and 7 base units. Now all these quantities have a scientific definition which you can read on your own. I will not go into great detail about these definitions. You can just look at read them yourself. We do not directly need the definitions, but we do need to know the definition. Now there are many other units which you can make from these 7 units. Those are called derived units. Now if you want to measure speed, for example, it is distance divided by time. Or you have the area. Area is length into breadth. Or some other geometric parameter, pi r square for a circle. And the volume is length into breadth into height. So you can have derived units. Some of the derived units have names and some do not have names, but they are made from the 7 base quantities. So now let's look at them. Some people use the word basic. It is not correct. It is 7 base units. Now area is meter into meter, length into breadth, you will get meter square. Volume is length into breadth into height, you will get meter cube. See, numbers like half and pi do not have any units. When you find areas and volumes, you will find these numbers. It is the dimensions which have units. So you have for volume, you have length into breadth into height. Think about the box, normal box. So it is meter into meter 3 times. So it is meter cube. Speed is distance per second. So it is meter per second. Your car, it is kilometers per hour, but for your scientific calculations, we'll be using meter per second. Acceleration is rate of change of velocity. So it is the velocity unit divided by time. So you have meter by second divided by second, you will get meter per second square. For vector quantities, you have to give a direction, and we will not be discussing that right now. Then you have the mass density, mass per unit volume. So it is kilogram per cubic meter. So kg per meter cube. Per means you have to divide. Then you have the current density, which we do not need. Momentum, eighth quantity. Momentum is mass into velocity. So what will be the unit for it? For mass, you'll use kilogram. For velocity, it is meter by second. So it is kilogram meter per second. Kg into meter second minus 1. You can per second you can write as power minus 1. Impulse has the same units as momentum. You must have seen this in other physics courses. So it will be kilogram meter per second. You can also say Newton per second. Impulse is a small force, is a big force acting for a short time. Force into small time, big time or small time, the units are same. So it is Newton second. Then frequency is beats per second, something like that. So it is second power minus 1. For force, the unit is Newton. What's the formula for force? Just think about a formula, you'll get the units. Force is mass into acceleration. So for mass, use kilogram. For acceleration, meter second minus 2. You'll get kilogram meter second minus 2. Pressure is force per unit area. So you'll have to divide the Newton per meter square. You will get kilogram meter power minus 1 second power minus. Work and energy have the same unit, which is what is work? One simple formula is force into distance. So it will be kilogram meter squared second minus 2. You copy the force from the previous line and just do it. Electric charge, coulomb is the unit. It is ampere second. Likewise, you can go on. And these are your units for from 15 to 23. It is about electricity and magnetism. Since we are not going to need them in this course, in this lab course, we will not talk about it. We'll also not talk about entropy, which is your chemistry and thermodynamics quantity. You also have it in physics in some other units, in some other chapters in another semester. So the first 14 quantities you will be needing in your physics 100, physics 170 and this lab course all put together. And the other quantities you will be needing in your derived quantities you will be needing in your other physics courses like physics 210 and 210L the next lab course. So you don't have to worry too much about all the units which you see here. There are many more derived units which I have not written because you are not going to need them in any other physics course in this university. These 24 units will suffice for all your physics and engineering courses. And the first 14 are related to mechanics, which we are going to use in Physics 170L laboratory course, which we are doing right now. And some of these units will be repeated during the experiments when we actually use them. Now we need some prefixes. You might have heard the word mega, milli, micro. See, these are adjectives. In the SI system of units, after every three zeros, the name changes. You have thousand, thousand is a million, thousand million is a billion. So likewise, when you multiply with thousand, the name changes. When you divide by a thousand, the name changes. Now, kilo means thousand. If you say kilometer, it means thousand meters. If you say kilogram, it means thousand kilograms. Mega means million. So if you say megawatt, it means 1 million watts. If you say megajoule, it means 1 million joules. Giga is 10 power 9, which is 1 billion. Then we'll not need more than that in any of our physics courses which we are going to do. This much is sufficient, which I have told you. Then the other suffixes are on the smaller side. You will need 10 power minus 2, which is centi, 10 power minus 3 is milli, 10 power minus 6 is micro, and 10 power minus 9 is nano. If you say nanosecond, it means 10 power minus 9 seconds. If you say micrometer, it means 10 power minus 6 meters. So these are your prefixes. Prefix is something which comes before. It's like an adjective in English language. If you say gigavolt, it means 1 million volt. There are, sorry, 1 billion. There are machines which can, devices, labs which have very high voltages for some special purposes. We can talk about it some other time. Now we have a set of solved problems. What is meant by SI system of units? Give them in detail. This is the problem one. See, SI system of units has 7 base units and 7 base quantities. The 7 base quantities are length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. Now what are the units? Units are, for length we will be using meter, the symbol is small m. For mass it is kilogram, the symbol is small kg. For time it is second, it is small s. For electric current it is ampere, it is capital A. For thermodynamic temperature it is Kelvin, it is capital A. Amount of substance is mole and the unit is symbol is mol, short form. For luminous intensity it is candela, it is cd. See, we have to list all 7 of them whether we use them or not. The system is complete with 7 base quantities and 7 base units. Now this is one type of question you have. You don't have to worry about the exact definition of these quantities, but you should know them. Problem 2. What are derived units? Give 2 examples in detail. Now your solution is derived units are made from the 7 base SI units. Examples are Newton equal to kilogram meter second minus 2. Joule is kilogram meter square second minus 2. Watt is kilogram meter square second minus 3. Coulomb is ampere second. Now problem 3. What are derived units? Express Newton and Joule in base units. Now again the definition is not going to change, only the English has changed in the question but not in the answer. Derived units are made from the 7 base SI units. Newton is kilogram meter second minus 2. Joule is kilogram meter square second minus 2. So you don't have to crudely memorize them, understand. Think about a formula. What is Newton? Newton is unit of force. What is force? Mass into acceleration. This is one way of looking at it. Now you know the mass unit is kilogram, acceleration is meter second minus 2. So your Newton is kilogram meter second minus 2. Remember it with the help of a formula. What is Joule? Joule is a unit for energy or work. Energy and work have the same units. So it is Newton meter. One formula for the force is, for the work is force times the distance. Not exactly times, you have to take the dot product, you have to worry about the direction, but it is force into distance if you are thinking about the units. So take the Newton's units, kilogram meter second minus 2. Multiply with meter, you will get kilogram meter squared second minus 2. Now, fourth problem is express 212 degree Fahrenheit in Kelvin. We do not read it right now. Your answer is 373 Kelvin. We'll discuss it in the lab if we need it. Next comes the multiple choice questions. Multiple choice questions are very important because many of your exams will be online, and in the online exams we'll be asking some multiple choice questions also. So how many millimeter are there in 0.06 meter? 1 meter is 100 centimeters and 1 centimeter is 10 millimeters. So multiply 1 meter is 1000 millimeters. So multiply 1000 into 0.06, you'll get 60. So 60 is the correct answer. How much is 7 kilometer equal to? 1 kilometers is 1000 meters and 1 meter is 1000 millimeters. So first answer is not correct. Second is also not correct. Third one is correct because it says 700,000 centimeters. So 7 kilometers is 7000 meters into 100 centimeters. So it is 700,000 centimeters. Next, question number 3. Convert meter square to centimeter square. Now, how much is 1 meter? 100 centimeters. Meter square means meter into meter. So 100 centimeter into 100 centimeters. You will get 4 zeros. 10,000. C is the correct answer. Fourth, convert kilogram square to gram square. How much is 1 kilogram? 1000 gram. Kilogram square means kilogram into kilogram. So 1000 gram into 1000 gram. You'll get 6 zeros. It is 1 million. So B is the correct answer. Convert meter cube to centimeter cube. 1 meter is 100 centimeter. So meter cube is 100 centimeter in bracket whole cube. You'll get 100 into 100 into 100 three times, which is 6 zeros. And your correct answer is B, which is 6 zeros. Convert kilogram cube to gram cube. This is the sixth question. How much is 1 kilogram? 1000 grams. Now 1000 grams whole cube. So 1000 into 1000 three times. How much do you get? 9 zeros. 1 billion. Count the zeros in the ABCD choices. First choice is correct. Count it very carefully because the commas are not written here. When 30 degrees is expressed in radians, we have, just think about it, pi radians is 180 degrees. So 30 degrees will be 30 divided by 180 into pi. You will get 0.523 radians. This C means radians and this full round means degrees. Same thing you do for 60. 60 divided by 180 into pi. You will get 1.046 radians, and that C is written on the radians. Same conversion you are going to do into when you are doing this. You will do 2.5 divided by pi into 180. You will get 143.24 degrees. These will be discussed in your one of your experiments when we do it in detail. Now, question number 10. Example of a base unit is, see, density is a quantity, it is not a unit, so that's ruled out. Newton is a derived unit. Watt is a derived unit. What are the base units? Ampere. So ampere is your base unit. C is the answer for 10th. Now example of a derived unit is, ampere is not derived, candela is not derived, Kelvin is not derived, joule is derived because ampere, candela and Kelvin are base units. 12th question, be careful. Which is not a base unit? Not a base unit. That means it is a derived unit. Henry is a derived unit because ampere is base unit, candela is base, Kelvin is base. So choose Henry. Henry has to do with your magnetism. Which is not a derived unit. Not derived in 13th. It means you have to look for a base unit. Which is base? Ampere is base. Just click it. Now some questions will have two correct choices. We'll see why and how. 14th is the unit of momentum is, now you can think about momentum in two ways. The first thing is force into time. So you'll get Newton second. The other thing is momentum is mass into velocity. So it is kilogram meter second minus 1. Both are correct. A and C for 14th. Impulse and momentum have same units. So 15th question is very similar to 14th. Nothing is happening there. 16th question. The unit of impulse is, now force into time. There is no force into time here. It is same as momentum. Mass into velocity. kilogram meter second minus 1. 16th answer. 17th, the unit of impulse is Newton second. It cannot be Newton meter because it is force into time. Think about a formula. Newton second is the correct formula. The wrong formulas belong to some other thing. Like for example, Newton meter is force into distance. It is work. So it's not impulse. The unit of force is Newton. The other choices are ruled out. The unit of force is, it cannot be Newton second square, Newton second cube are wrong. So what you have to choose between C and D. C is unit of force is mass into acceleration, kilogram meter second minus 2. Then again, the unit of force is, you'll rule out all of them. The correct answer is Newton or kilogram meter second minus 2 I have written here. So for 28th, the choice is none of the above. Now, the unit of force is, you can also make it from watts. So you'll get watt meter minus 1 second. Then the unit of work is 22nd, Newton meter. 23rd, the unit of work is Joule. Then again, 24th, the unit of work is kilogram meter squared second minus 2. So 24b, all these questions are similar. They are just using the same idea again and again. The unit of work is watt second. What is watt? Watt is the rate of doing the work. Work divided by time. Joule divided by second. So watt equal to joule divided by second. So work. So joule will be equal to work into second. Watt into second. WS. The unit of power is rate of doing the work. Joule divided by time. Work divided by time. It is joule second minus 1. The unit of power is watt. If you look at your electric bulbs, it will be written the power rating is 60 watts, 40 watts. Yes. The unit of power 28. You will see all of them are wrong, so you have to write none of the above. 29th. The unit of power is kilogram meter squared second minus 3. Power is joule by second. Joule is force into distance. So Newton meter by second. Then put the Newton there, you will get kilogram meter squared second minus 3. Now in 30th, if you have a dot on A, it means angstrom. In your optics and atomic physics, the distances are very small. So we use a unit which is very smaller compared to the meter. It is 10 power minus 10 meter. So 1 angstrom is 10 power minus 10 meter. Convert angstrom square to meter square. It is just like your initial question. So it is 10 power minus meter square is meter into meter. 10 power minus 10 into 10 power minus 10. It will become 10 power minus 20. Angstrom cube, 10 power minus 10 whole cube. You will get 10 power minus 30. Now 33rd, what are the units of the constant k in the given equation? P equal to kfl square. This is some formula from somewhere. Don't worry where the formula came about. Where P is the power, F is the force, L is the length. Now power is joule divided by second. Force into distance by time. Cancel the force. Distance by time, L by T. So you can cancel the L also. So K will be 1 by LT. L is length and T is second. So it is 1 divided by meter second, which is meter minus 1 second minus 1. Just write it with a piece of paper and do it. 34th, same thing happens here. F equal to G m1 m2 by R square. This is the famous formula of Isaac Newton describing the gravitational force. So now what's the unit for gravitational force? Take everything to the left. You have Fr square divided by m1 m2. How much is F? F is the Newton, kilogram meter second minus 2. Multiply with R square, it is meter square. Divide by kg square, you will get kg power minus 1 meter cube second minus 2. These are the units. Nobody memorizes them. Look at the formula, do the algebra and get them. Now if you go to the port, kilogram becomes a very small unit for the port people. For the market people, they will say 1 quintal of rice. 1 quintal means 100 kilograms. That big bag of rice is 100 kgs. Nowadays, they don't sell many 100 kg bags in the market because they are difficult to lift. They normally make 50 kg bags. But sometimes you find these things in the market. So quintal is 100 kgs, ton is 1000 kgs. So 5 tons is equal to 5 into 1000, you'll get 5000 kilograms. 6 quintals is 6 into 100 kg, which is 600 kg. Megawatt. Megawatt means million. It is capital M. So megawatt is 20 megawatt when expressed in watts is 20 into 10 power 6, because 1 megawatt means million watts. Million is 10 power 6. 10 watt hours are equivalent to, see, these are the units which your Dover power company uses. 10 watt hours. 1 watt is 1 watt. Hour is 60 minutes. 1 minute is 60 seconds. So 1 watt hour will be 1 watt into 3600 seconds. 1 hour is 3600 seconds. Multiply 10 watt hours, you will get 36,000 joules. Now horsepower. See, the horsepower is 746 watts. So 10 horsepower will be, HP means horsepower is 7460 watts. Now convert 20 millivolts when expressed in volts is, the English is not very good. Millivolt means this is not meter volt, this is millivolt. Milli means 10 power minus 3, so you'll get 20 into 10 power minus 3. Convert 6.5 feet to 1 centimeter. See, 1 feet is 30.48 centimeters. Your scale is 12 inches. 1 inch is 2.54 centimeters. 2.54 into 12 will give you 30.48. These numbers you can get from books or the internet. So 1 feet is 30.48 centimeters. How much is 6.5? 6.5 into 30.48. Use your calculators. You'll get 198.12 centimeters. The SI unit of current is ampere. Correct. What's the SI unit for temperature? It is Kelvin. Now here we have some 9 practice questions. Go through them. We'll discuss them in the class, and let me know if you find any one of them difficult. So this is all about the units. You have to be careful about the magnitudes, the prefixes. Use the correct units. You have to use kilograms in your calculations and not grams. That's the only thing which is in kilo in your scientific calculations. Otherwise, you have to use meters and seconds. For this Physics 170 lab course, it is sufficient to know more about kilograms, meters, and seconds and your mechanical units, and the other electrical units and the magnetism units we do not need in this course, so we'll not look at them in detail. That's why I did not put any multiple choice questions on electricity and magnetism units. See you soon inshallah in the class. Let's discuss if we have any issues. Assalamu alaikum.